Hello, in this video we'll be assembling a gear train that consists of 3 mesh spur gears, with the last one connected axially to a worm driving a worm gear. We're actually going to break this down into 2 sub-assemblies, the spur gear assembly and the worm gear assembly, and we're going to fully constrain each and then bring them together in our final overall assembly and add in the long rod with the spur gear and the worm that really connects the 2 sub-assemblies together. So let's start with the spur gear subassembly. I'm going to open up a standard millimeter assembly file. And the first thing we're going to do is place the mounting bracket grounded at the origin. So I'll go to the place button in my assemble toolbar. I'll select the spur gear mounting bracket to open up. And then I'll right click and select place grounded at origin. Now that we have this part, I'm going to right click and press OK. And I'll just rearrange my view. And now we can place all the other components around it. So one cool feature of Inventor is if you press the space bar, it will bring up the very last command. In this case, it was the place command. So I just press space and now I can select my short rod, where I will place 2 short rods in this subassembly, and then select OK. I'll press space again to bring up the place component window again. And I need to select a 24 tooth gear to place in this assembly. And one more time, I'm going to select a 12 tooth gear to place in this assembly. So there we go, we have all of our components in our assembly file. Now I'm going to go to View and select Degrees of Freedom so that we can see all the degrees of freedom of our non-grounded parts. And now we can go ahead and start applying constraints to remove these degrees of freedom. So I'm going to start off with the short rods that we have. We know that we want these inserted into these holes. Luckily, our mounting bracket already has holes, which have been placed according to the center distances of our gears. So we can just go ahead and insert these rods into our mounting bracket. So I'm going to press C to bring up the constraint tool. That's also found in the Assemble tab right here. And I'm going to select the Insert constraint, and I'm going to insert the rods into our mounting bracket. Let's change the direction there and press Apply. Note that I'm not going to lock the rotation just yet, so our rod still has a rotation degree of freedom, but otherwise all the other degrees of freedom are removed. And I'll just repeat the process with the second rod and apply. So now we have most of the degrees of freedom of these rods removed. All that's left is the rotation, and now I'm going to move on to the gears for now. So we know that these gears should be mounted on the rods, so that will be an axis mate constraint, where I mate the gears to the axis of the rods. I'll do that for each of my gears. And last but not least, we see that we want the faces of our gears to be flush with the ends of the rod. So I'm going to select the flush option for the mate constraint and apply this last constraint to our gears. Okay, so now our gears have a rotation degree of freedom, our rods have a rotation degree of freedom, and we probably want the gears to be spinning along with the rods together. So we can use a mate constraint to mate one of the origin planes of the gear to an origin plane of the rod. So I'm going to go to the assembly browser, and for one of my short rods, this is the first one, I'm going to mate the YZ plane of this rod to the corresponding plane of the gear. So now that removes 1 degree of freedom, we see the little green box here. It's actually constrained to the rotation of the rod as well. We're going to do the same with the second rod gear pair. And we'll apply that. And now all that's left is the rotation of these 2 gears and their corresponding rods. So in reality, we want these gears to be able to rotate around, but for the purposes of this assembly, I'm going to fully constrain everything. So I'm actually going to pull up the constraint tool again and I'm going to use an angle constraint to constrain one of the origin planes of our gears to be aligned with the side face of the mounting bracket. I'll just use a directed angle constraint for this, and I'll apply it. I'm going to do the same for our other gear. And you can see that this actually makes the teeth interfere, but we won't worry about this for the purposes of our assembly. This brings our degrees of freedom to 0, but for our next topic of dynamic simulation, we'll actually leave these gears free to rotate as they should, and we'll apply a different type of constraint instead, a motion constraint. But for now, all of our degrees of freedom are eliminated in this assembly, so I will save it as my spur gear subassembly. And now we can repeat the process with the worm gear subassembly. So I'll open a new file, standard millimeter assembly file. I'll place all of the components, which is the worm gear mount. This will be placed grounded at the origin. We need another short rod. And finally, we need our worm gear. So if we view degrees of freedom again, we see that we need to constrain the rod and the worm gear, and this will be very similar to what we did with our previous subassembly. So we're going to mate the axis of the rod to the axis of the hole in the worm gear mounting bracket. Last time I used an insert constraint, but this time I can use a mate constraint coupled with a flush constraint to achieve the same end product, so our rod still has a rotation degree of freedom remaining. Now we can go ahead and apply an axis-axis mate constraint between the rod and the worm gear. And finally, we can apply a flush constraint to the worm gear and the rod. So now both of these components still have a rotation degree of freedom. So again, I'll go to their origin folders and mate two of their origin planes together. And then finally, I'll apply an angle constraint between one of the origin planes of the worm gear and one of the side faces of our mounting bracket. Again, in reality, we want this gear to spin, but for now we want to fully constrain everything, and we've accomplished this purpose. So I'll save this subassembly as worm gear subassembly. And our next step will be to open a third standard millimeter assembly file to bring everything together. So now I'm going to go ahead and place my subassemblies into this file. I'll start with the worm gear subassembly. I'm going to place this grounded at the origin. I'll press the space bar to bring back up the place component window, and now we can place our spur gear subassembly. If we want to rotate this, we can right click and we'll rotate 90 degrees about the x-axis and 90 degrees about the y-axis. We'll have to do this 3 times to get it to rotate in the correct direction, and we can place that as well. And we also have to place a long rod, which I'll rotate 90 degrees in the y direction. In addition to a 12-tooth spur gear, which we'll also have to rotate. And finally, a worm. So now we have all of our components in our assembly file. And we can go ahead and start constraining things. So the first thing I'm going to do is constrain our spur gear subassembly to the grounded worm gear subassembly. So I'm going to pull up the constraint tool by pressing C, and we're just going to apply a bunch of flush constraints. So I know that this side face of my worm gear mounting bracket should be flush with the corresponding side face of the spur gear mounting bracket. We also know that the bottom faces of these two mounting brackets should be flush. And finally, we know that the back faces should also be flush. And there we go. So now we have to constrain the three components that we added into this assembly individually: the spur gear, the worm, and the long rod. So let's start with the long rod. We want to apply an axis-axis constraint with the corresponding axis of the mounting bracket. This should be equivalent if we choose either the whole of this axis in the worm gear mounting bracket or the corresponding whole axis of the spur gear mounting bracket. And we also know that we want the end of the rod to be flush with the end of the mounting bracket. We also want to apply axis-axis mate constraints between the worm and the rod, and the same thing with our 12-2 spur gear. We also want the face of our spur gear to be flush with the faces of the other spur gears. And if we look at the drawing, we want the distance between the mounting bracket and one face of our worm to be 20 millimeters. So I'm going to apply a mate constraint. Select the one face of the worm and the face of the mounting bracket. And I'm going to apply an offset of 20 millimeters to get the desired result. If we go to the View tab and view our degrees of freedom, we'll see that the spur gear, the worm, and the rod all have a rotation degree of freedom remaining. So just like before, we have to mate the origin planes of these elements together and then mate one of them to, say, a side face of our mounting bracket. So I'll go ahead and do that. And with that, we've fully constrained this gear train assembly. Again, you can see that there's interference between our gear teeth, but we won't worry about that for the purposes of our assembly model. As long as we know that the modules of the gears are correct so that they can mesh together properly, then we're fine. In one of our next videos, we won't actually fully constrain the gears. They will still be able to rotate, and we're actually going to have our input gear impose motion on the other gears, and we'll create a simulation of this. So stay tuned for that.